For day 7, we're going to be taking a look at obtuse angles and gradients. This is so Alright, so the first one we're going to look at is we're asked to find the x and y coordinates of a 35 and 145 degree angle. So if we take a look at this, a 35 degree angle, 35 would be right here. And so if we were to make a right triangle again, like we were doing with the 30, 60, 90 triangles, this is 35 degrees. But we don't know what the x and the y are. So we can have x and y, and it's on the unit circle, so our hypotenuse is 1. So this, let's see, this is, let's switch this around. Let's make this the x and this side the y, over x and up y. So if we were to find x, that's adjacent over hypotenuse. So the cosine of 35 equals x over 1. Well, that's just the cosine of 35 equals x. And then we can go to your calculator, make sure it's in degrees. Trig cosine of 35. So 0.82. So x equals 0.82. And to find that y value, the sine of 35, because that's opposite over hypotenuse, equals y over 1. So the sine of 35 equals y. And we can type that in, the sine of 35, and we have 0.57. So y equals 0.57. So the x and y right here, we would have 0.82 and 0.57. We're asked to do the same thing for 145. Well, 145 is in this quadrant. Well, what is our reference angle? Well, 180 minus 145, we end up with 35. So we have x, y, and 1. Well, we can set this up again. The cosine, so c, adjacent over hypotenuse, is just our x again. So we know our x is 0.82. And our y value, once again, would be the sine of 35, gives us our y. It's that same thing. So y equals 0.57. The only difference here is this x, it's going backwards, so it would be negative 0.82 and 0.57. So the next thing we're going to do is we're going to talk about slope again. And we're going to add on a new vocab word. Often slope is also referred to as the gradient. And slope, those are words, rise over run. We've done it before where with coordinates, where it's y2 minus y1 over x2 minus x1. And when we look at these values that we've done in our triangle here on this, we have x and y, so that's our y over x on this triangle. And we know y on the unit triangle is our sine over our cosine, which we also know is our tangent. So looking at this next example here, we are asked to find the gradient of the line which forms a positive angle of 130 with the x-axis. So it's a 130 degree angle. So this angle here is 130. And we're going to turn this into a triangle again. So if this is 130, down here has to be 50. So we can find this x and y. So let's see here. The sine of 50, we would have y over 1, which is y. The cosine of 50, x over 1, which is just x. So let's see what we get when we type those in. Sine of 50 and the cosine of 50. So we have 0.64 and 0.77. So this is 0.64, 0.77. So right here, 0.64, 0.77. And we have to find the slope. Well, opposite over adjacent. So our slope, y over x, 0.77. This is negative 0.64, since it's going backwards. We can go here, and we could just go up and say, take those. So this divided by negative, oops, go back, negative 0.64. We end up with negative 0.19. And you guys might notice here, well, opposite over adjacent, rise over run. Another way to look at that is the sine over cosine, which is our tangent. So if we were just to type in the tangent of 50, so this is a second way of doing it here, we should get that same thing. So trig tangent of 50, we get positive 1.19, but we know it's in this quadrant and it's a negative line, so we'd have to say negative 1.19. So in this case, we're asked to find the gradient of this line, so our slope. So x and y, and we could just say our hypotenuse is 1. So once again, we can see, well, what's the cosine of 60 and the sine of 60? So we got sine, whoops, of 60, cosine of 60, so 0.866 and 0.5. And I'm going to add that's negative 0.5. So rise over run, we have 0.866 over 0.5. So we have 1.73. Or some of you might be looking at this and saying, well, that's rise over run, that's our tangent, y over x. So let's check at the tangent of 60. Make sure we get that same thing. 1.7273. Oh, looks like I added too many sixes. So we have that same thing. But one thing I notice here is this line's going down, so we need to add that it is a negative. All right, a couple more that we're going to look at here. So this one, find the equation of the line passing through and find the value of theta. So we have some coordinate out here, and we know that this is 0.674 and this is 0.738. We go over and up. So let's see, to find that angle, inverse tangent, 0.738, opposite over adjacent. So, and we had 0.738 divided by 0.674, so 47.6 degrees. So there's our angle, and now we have to find the equation of the line. Well, y equals mx plus b, but we know our intercept is 0, so it's just y equals mx. So we basically have to find that slope. What is our rise over run? Well, 0.738 divided by 0.674. That's our rise over run. So we have 1.09. So our equation would be y equals 1.09x. And then the last one that we're going to look at. We are asked to find this angle, and I believe the angle it's talking about is this area right here. So we're given this coordinate. So if we were to make a triangle right here, we know we go backwards 2.2, and we go down 4.1. So again, we need to find the equation of the line. So what is our slope? Our rise over run, negative 4.1. divided by negative 2.2, negative 1.84, was it? 1.85. Feel I added an extra 2. Let's see if that makes a difference. $1.86, okay. and it's positive, so our equation would be 1.86x. So we can't find this angle, but we can find this angle right here by doing that inverse tangent again. So the inverse tangent of 4.1 over negative 2.2. That tells me that angle is 62 degrees. So we got 62 degrees right here, but we need to find just this part. Well, the whole thing's a line there, so 180 minus 62, 128 degrees. Whoops, 118 degrees. My bad, I feel like minus 62. Yep, 118 degrees. All right, so this last one here, you guys are asked to try this last one. Try with a partner, so see if you can find that, which one's a positive angle, which 135. And I believe that's pretty similar to one we did at the beginning, so you can check it with that.